going to cover how to draw an architecture diagram or how to reason about architecture using the tools that I usually use. Um, One of the things about creating great architecture is that if your notations are sorted out, then your architecture also usually is comes out good. This is because your notations actually influence the way you think. And in this video, I'm going to cover and I've been meaning to do this for a while now. I'm going to cover the notations that I use and the tools that I use to create, architecture diagrams, right? And they're not like super complicated tools like Archimate or they're not like very specific UML diagrams, although I do delve into or dive deep into UML when it comes to code level diagrams. But when you're talking about like a 50,000 feet view and then double clicking deeper and deeper, I use like very simple tools that really help me think about architecture. And the tools that I use are mostly modeled or helps model us towards like static diagrams over dynamic diagrams, which is they really help us capture the structure of the system. And then we dive deep into once we have the structure out. When you talk about structure and you talk about behavior, there is always like an interdependency between the two. But you start off with some high level idea of what you want out of the system. And then you dive deep into, how the system is structured in order to achieve that goal. Right? That's how you really reason about architecture, how you reason about systems, or how you generally reason about things, right? You have like a goal, the end state of your system, and from that end state and a current starting state that you have, you think about how you can get to that end state. And modeling and diagrams are like a way to visualize those steps one after the other, right? And so the tools that I use, as I said, are like pretty basic. Like I start off with using PlantUML. I use Visual Studio Code, which just helps me visualize the PlantUML code that I'm writing. And on top of that, I also use a particular diagram notation called as the C4 diagram. So it's nothing complex. I'll dive deep into that. But along with that, I also use like a plugin for C4 diagrams, right? So now I want to just briefly touch upon what C4 diagrams are, but before that, I'll talk about the C4 diagram plugin for PlantUML, right? So this is a plugin here. The GitHub link will be in the description of the video. It's by Ricardo Naipel. It's called C4 PlantUML, and it's a brilliant plugin that you can put along with PlantUML to enable C4 diagrams on PlantUML. Right, so let's get started with a very basic PlantUML diagram that shows various types of C4 diagrams, right? So I want to start with just saving this file as a PUML file or a PlantUML file, so that um, all the code completion stuff comes up, right? So I'm going to save it as context.plant.uml. So system context diagram is the first diagram that we start off with. The other thing is, in order to set up autocomplete for Visual Studio, you will also have to install a extension or a plugin on Visual Studio called PlantUML, right? It's like a brilliant plugin for PlantUML that gives a lot of code coloring, a lot of features that really help you with working with PlantUML. It has basically some dependency on PlantUML as well. But yeah, it gives you a beautiful way of visualizing your PlantUML diagrams as and when you type, and it also gives a autocomplete on PlantUML code, right? So once you have this Visual Studio set up, once you have PlantUML extension set up, all of these things will be in the description of this video. Once you have all these things set up, you can just go back to the context diagram that you have the context diagram that we created. One more minor thing is that in the PlantUML plugin that I talked about, this is for PlantUML, not for Visual Studio Code. Setting up that plugin is super simple. You just have to copy this URL and put it on your PlantUML code, and you get all the macros along with it. But the one thing that I want to talk about is you can add snippets for Visual Studio Code. This really helps out with the speed at which you can build your PlantUML diagrams. Although these are not like super mandatory stuff, they just help you with the productivity when you are using PlantUML. The link to this plugin will be put in the description, but yeah, like a high level, you just have to enable this snippet in Visual Studio Code as well. And it's a super simple to do that, right? There are instructions in the GitHub for that particular plugin, and you can just like go through that and figure out how to do it yourself. Now I'm going to start off with a quick PlantUML diagram. So the snippets are all here now. So when I do like a start UML, it will give me a suggestion, suggestion of the autocomplete suggestion, and I'll say it's a blogging context, right? So this is the first diagram that we are going to have. This is called as a context diagram, right? The context diagram is basically a 50,000 feet view of your system, right? So this basically talks about who are the actors in your system and what are the operations that those actors are doing on your system, right? You can think of this as like a use case diagram in the UML context. So you start off with defining an actor, right? So let's say you have an actor. Now, if you saw how the autocomplete worked, the autocomplete worked because of the plant UML extension. So before that, I need to include this plant UML extension in the plant UML file. It's as simple as just copying and pasting this URL. So once you do this, you have all the PlantUML macros in your that PlantUML can process. So now you can just hit person and the autocomplete works. And you can type some alias. Let's call this as an author, and I'll say this is the label will also be as an author. And then I'll say, hey, we also need a system, right? A system. We'll call it a blog and a blogging system, right? Let me just call it Acme Blog. Right? So, I mean, when you hit the PlantUML plugin automatically renders the diagram that's there. So if you can see the diagram come up, it basically talks about a person called author and a system called Acme Blog, right? Now, in the system context diagram, you basically define what is the action that the author has on the system, right? So you do that by defining relationships, right? So you can have a relationship or you can have a relationship with a technology. I'm going to start off with a relationship. In this relationship, I'm going to say author and to the system blog. And the action that they can do is like say create a post, right? This basically means that the author is passing some request body to create a post in the Acme blog, right? So this basically creates like a arrow from the author to the blog and with a title saying create post, right? This basically says that the actor person can create a post on the system blog or the Acme blog, right? The second thing is like we can have a relationship with technology as well. This basically allows us to specify the technology through which this particular action can take place. So you have like say update post, and let's say it happens over HTTP, right? So this basically tells us that hey, this particular update post call happens over HTTP. It could be RPC, it could be like whatever other means in which the author communicates with a blog system, right? So if you can see that the update post has also come up and there's a create post, right? And then let's introduce another actor called as a reader, right? A reader is someone who's external to the system who will be basically reading the particular blog, right? So a reader has the ability to read a blog. So we'll say read post, and they'll be reading again on top of HTTPS. Right? Both will be HTTPS, so they will be reading these blog posts on HTTPS by say opening a particular URL. Right? So the same thing also like comes up in the diagram once we update it. So you can see like there's a person and there's an external person who's a reader. And the person is basically able to create a post and then update a post. The reader has the ability to read a post, and all of these things happen on the system called as Acme Blog. Right? So this is like the 50,000 feet view of your system, right? You can add other use cases also, like say a delete post and stuff like that. But to keep this video shorter, let's not like cover 10 different use cases. Let's just stick to these three use cases, because the intent behind this video is not to really talk about a blogging system, but the intent behind this video is to communicate how C4 diagrams, how PlantUML, and how the ecosystems looks like, and what are the notations that really help you think better about architecture, right? And obviously, we can add this is a PlantUML feature where you can add like a title on top of your diagram that helps you, just like put that on top of your image so that when you share out, the title also comes as a part of this image too. Right, so you have that particular blogging context. You have the actors, you have the external actor, and you have the system. And this is like as I said, this is the 50,000 feet view. This is basically there's a one abstraction called as the blog, the Acme blog, and what are the various actions that these actors are taking on that particular blog. Um, it's demonstrated here. But this is like the 50,000 feet view. Now next you have to go a little deeper, right? You want to understand what are the various components of this, Acme blog that basically allows these set of behaviors to, occur in the system, right? So for that, there's the next type of diagrams that are there are called as, these container diagrams. Now you have to note that container in a C4 diagramming context is not the same as the container in a Docker context, right? While they are like more or less similar, like containers can be thought of separate deployed services, right? Whereas containers in Docker or in Kubernetes world are the things that are basically running an isolated set of code, right? So now, if you think about it, container can be the very high level way can be thought of as a service, right? So in this Acme blog, we have to think about what are the services that are really required in order to, create a post, update a post, read a post, and stuff like that. Now, if you think about it, this create, update, and read and stuff like that are like more or less, since the system is simple enough, can be encapsulated within just one service. But in reality, most of the systems are complex and they can have multiple services. Even if you think about like a blogging system, you can like make it a little more complex by adding a search feature and a service that is responsible for doing search. You can have a notification feature that basically notifies various readers when um, a new blog post come, and that can be handled by a separate service and a number of things like that. So, just to make the discussion more prominent and show some other features of, how C4 diagrams can look like that, I'm going to add two more use cases to this particular blogging system. The use case one is going to be, it's going to support search, and use case two is going to be that it's going to support notifications in some shape or form, right? So that's like, in order to dive deep into that, like we can go into the next diagram called as the container diagram. But before we do that, like let me just add those use cases here as well, just to ensure that the system has some more meat into it, right? So I'm gonna say that the blogging system itself will notify the reader, and I'm gonna say, hey, this is gonna use email as a technology, right? And the other use case, we can have it as a reader can do a search on search post, and again, it's going to be on HTTPS, and let's like more like update the PlantUML diagram. So the whole reason for doing this is again to show multiple containers and not just how one single container um, in our blogging system. So like I've made this a little more meatier. I have added create post and update post. as the actions that the author person or author actor will do. And then I've added like some more features like a search post and a notify of new post whenever like a reader are those features for the reader, right? So as I said, like let's dive deep into the second type of diagram, which is called as the container diagram, as I already talked about. The container diagram basically shows the various services that are there in the system, right? So I'm going to create a new file. I'm going to save it as container.pml. PML basically, helps Visual Studio Code know that this is a PlantUML file. I mean, this container diagram, I'm going to say, it's called as blogging container. I'm just going to call it blogging container, which basically means that this is a container diagram, right? And then what I'm going to do is let's just get started with the blogging container. Now, in any case, it's always prudent to have your actors and show them that they are doing some action on the system. The reason is it just helps you reason about things much better, right? So now you have like a system boundary. System boundary is like basically encapsulates a set of containers, right? In this system boundary, I'm still going to call it as blog, and I'm going to call this as Acme Blog, right? And within this system boundary, let's say we have, so this system boundary basically encapsulates multiple services under it, right? So we talked about a search use case, we talked about a notification use case, and we talked about a simple CRUD use case that we had, right? Again, I need to include this particular URL for the diagram for the macros to come up. So now, in order to think about these different use cases, they seem to have their own bounded context, right? Like a search is a different bound context compared to a notification, and that is a different context compared to create, read, update, and delete of a particular blog post, right? So now let's start off with like the core entity that we have in the system, which is the blog. And we'll have like a blogging service, right? The blogging service basically will allow CRUD on top of all these blog posts, right? So let's start off with like a container now. Like notice the word, it's called container. I'm gonna call it as blog blog service. You can use camel case, you can use you can use whatever snake case, kebab case, that's your choice. I'm just more comfortable with you know, camel case, so I'm going to use that. So you call this as a blogging service. It's basically a service that enables blogging for the user. And let's say the technology that we are going to use is this is a typical let's say drop wizard or a Spring application, right? So we'll call it as drop wizard. This is like a plain old drop wizard. We can add yeah, this could be like a simple drop wizard based application, right? So now you have like you can see that the diagram has updated itself with the blogging service details, right? Now let's dive deeper into this system, right? Let's create an action on the system which the author is going to do, right? Let's say let's create that's basically depicted by a relationship. So we have a relationship from an author to the blog service. This will obviously be like load balanced. There will be like a ELB sitting in front of it. All those things can be shown in like a deployment diagram, not really required in this particular diagram. And we can say that the action that the user does is like, or the author does is a create post and sends the post details. Again, these are like these diagrams increase in the detail as they go deeper and deeper. At this level, it's not really necessary to show the payloads that go from the author via front end to the blogging system, right? So therefore, at this point of time, we are not gonna like really talk about what is the data that goes in the create post request. That comes way down below when we talk about a type of diagram called as the code diagrams. Okay. Now, like here also, if you see the relationship is between an author and a blogging service. But in reality, it's never going to be directly to the back end, right? There's going to be like a front end, like an admin panel or something like that. Let's depict that as well, right? Let's create like an admin panel where the authors are going to um, create the post and stuff like that, and then the admin panel, the admin front end is the one that's going to talk to the backend. We'll say it's an front end based on React.js, for example. So the author then gives like a create post on the admin panel, and the admin panel is then going to communicate to the blogging service, saying create post. Again, as I said, the granular details, come in the subsequent diagrams, not in this diagram right now. This is just like the next level from the system context, right? We go deeper and deeper and become more and more granular, and that's the way how you reason about systems, right? You don't like start getting all granular about details from the get-go. You start with a 50,000 feet view, you then go to a 25,000 feet view, and then you finally go into more in detail, and finally you end up with this actual code, which is the most detailed thing that can be there. So now if you can see, the author did a create post on the admin front end. The admin front end subsequently calls the blogging service, which is a backend based on drop wizard. And now let's say blogging service is going to store it in a DB, right? So we have a container DB, right? And this is basically so this basically is the database for that particular container. Apologies, I have basically forgotten what's the actual. Yeah, it's container DB. There's a alias that's missing there. So basically, you add a container DB, and that should contain. Yeah, there's an alias missing, but yeah, this container DB basic is the one that you'll be using to represent a database, right? So let's say we are going to go with like a MariaDB. Again, I apologize for forgetting the syntax for this. It's been like yeah, I don't think they have really given syntax. Well, I'm just going to call it blog DB, right? I'm going to say blog database. Let's see if this works. If not, I'll have to dive deep a little to find out, what's the exact syntax for that. But yeah, let's hope that this actually works. Or I could just like yeah. So there's some issue with the component DB. Yeah, okay. This basically also needs a technology along with it. So I'm gonna say, hey, this is based on Maria or MySQL, right? This is a MySQL database. Let's say, and let's see if this works. Great. Again, I apologize. I forgot about the syntax here, but I don't. I think yeah, we are good with it now. So now the blogging service, let's say, it eventually writes onto this, the blog. The blogging service actually writes down to the blogging DB, right? So we create a relationship. Let's say we also mention the technology. We go from blog service to a blog DB. I will say insert. Now the terminology here is more, database specific. We have insert statements, but in CRUD we create an entity, right? So therefore, I'm going to call it as insert post row, just to make sure that we are like in line with how the database terminologies are. And let's say it happens over a JDBC connection, right, which is our technology. Now it could not, it's not necessarily directly JDBC. You could have like a Hibernate or a JDBI layer on top of it that does the connection pooling and stuff like that. But at a very raw level, it's going to be like JDBC is going to be used to make a write to this particular database. So now if you see, there is like a clear, direction from the author to the admin front end, and then to the blogging service, and then finally to the blog database. Just to make it clearer, I'm going to call it as BlogDB, right? It's just like a database name for, the database which stores the particular blog related information, right? So this is like one particular user behavior that is, demonstrated with this particular diagram. But one key thing to note is this type of diagram, the container diagram, is not the ideal diagram to understand how a particular user flow works, right? That's a dynamic diagram. Now, what this diagram particularly helps is to you can just take like a couple or two containers and see what are the communication that happens among them. It's not an ideal diagram to track the entire flow from create till the database, because as the system gets more complex, there's going to be more arrows here. Sometimes semantically you can figure out what is the particular flow of data, but this type of diagram is not really ideal for identifying that. To identify behaviors of that sort, there are like better diagramming techniques, right? You can use uh, dynamic type of diagram. In C4 itself, there's something called as a dynamic diagram, or you can use a sequence diagram in standard UML. Those diagrams are much better at depicting dynamic behavior. Here we are depicting some static behavior, right? So now let's say there's another behavior of an update post, right? So let's say we create an update post as well here, right? I'm going to just add a relationship and say update post, and then again, let's say the admin will talk to the blog service to say update post, and then finally, you know, um, the blog service basically does an update post row, right? So now the use case of update is also captured here, and the way you understand that, hey, this is the data flow that happens for update purely comes from the semantics, right? Like there's an arrow from author to the admin front end saying create post, and then there is an arrow from admin front end to blogging service again saying create post, and that's how you make sense that, hey, this is the flow that's happening. But this diagram does not specifically mention that. This does not say that after create post, the admin front end does a create post to the blogging service or does a update post to the blogging service, right? That is something you understand semantically from. But a more structured way or the more proper way of showing these types of dynamic behaviors of a particular user action till its end is more captured via like a sequence diagram over a container diagram. The container diagram gives the 25,000 feet view of what are all the communication that's happening from one container to another container, right? So from this like particular diagram, it's very clear that from a blogging service to the blogging DB, there's an insert post row going and there's an update post row going, right? But it never talks about, hey, create post is triggering an insert post row or an update post action on blogging services triggering a update post row on JDBC via JDBC on the blogging DB, right? Those things are much captured much better in a much better way in say a UML activity diagram or a sequence diagram. But this is just like the the next 25,000 feet view of how the system is structured, right? Now, we also talked about two other use cases, right? We talked about a search use case and we talked about a notify new post use case, right? So let's go to the notify post use case, right? If you think about it here, a notify can be like a synchronous call or it could be an asynchronous call via a message queue, right? So let's say there is another notification service, right? We have a notification service here. I'm going to call it notification. Let's say this is a notification service. And this is, let's say, again, based on drop wizard, right? So drop wizard is a container, not drop wizard is basically a Jetty container. Drop wizard is basically an amalgamation or configured Jetty for you, right? So you have your Jetty, Jaxeris, all those things are configured, and opinionated form of those things are is basically drop wizard. So now you have, another notification service that's come up in our system, right? And now this notification service needs to be told that, hey, this is the thing that you have to notify, right? Now, there are two ways to achieve this. One is that blogging service is directly, calling the notification service and saying, hey, notify all these users. But, the ideal way of going, the issue with that is like, what if notification service has gone down, right? So you have like a highly available or a highly reliable message queue in between where the blogging service just dumps an event onto that message queue, and notification service reads from it and uses that message to then propagate to the reader. Now there's a one minor thing that I said was that highly reliable message queue and needs to be used in case notification service goes down. But that's not the reason to use a message queue, right? If the problem is that the notification services can go down and that's why direct communication from blogging service to notification service shouldn't happen, then you make your notification service more reliable, more available, more fault tolerant. Bringing in a message queue is not the ideal solution for such use cases. But the real use case for having a message queue in between is to make sure that the system is ready for proper pub sub, right? Many other services like a search service is also interested when a node post is created or an updated. Right now, I'm not saying this is my opinion. I'm not saying that bringing in a message queue in between because your other services are not fault tolerant, not available is a bad solution, but just that in my opinion, if you can like increase the quality of your service itself, you'd rather do that. The reason to bring in message queues in between is to avoid things like callback hells, enable proper pub sub in your system, right? But in pragmatic, in being realistic about things, it does make sense to bring in an SQS in between if you have to make sure that the systems are available. But if you are like a solid high bar engineering team, you would rather make sure that your systems are as reliable as SQS over relying on the reliability of SQS. Anyway, rant aside. Now going back to this architecture, right? So we want a pub sub mechanism to be enabled whenever like a mutation on a post occurs, right? And that pub sub system is basically going to be used by say a search service and a notification service. So let me like bring in a message queue in between. Now here's the thing: C4 diagrams does not support like a message queue itself in a diagram, but you can just for convenience sake use the DB diagram and just say that hey, this is a message queue, right? You can just put it here. Say you can call it an event bus. Um, you can call it an event bus, and let's say this is based out of Kafka. Right? So that comes up in the diagram here. Um, Now, the two things are happening here, right? One is in the event bus, the blogging service will notify the event bus that. So the blog service will send an event to the event bus saying post updated, right? So this basically will send a message from the blogging service to the event bus, and the message will be say post updated with some post ID along with it, right? Where is that post up? Right. Now, the notification service basically uh, will call a read messages, right? Will basically try to read the messages that has come to that particular event bus on a particular topic, right? So notification service now reads message from that event bus, and once the notification service, reads some message, it basically then has to notify the person the external person who's the reader, saying that, new post notification goes to the, reader, and let's say it goes via an email. Right? Now, again, a nuance is here. Again, you can think of a nuance in this, and the nuance is that the notification service might not like directly, uh, you know, send the message to the reader, but there will be like an external system in between, right? Let's say that external system is something like a Twilio. So we have like an external system here. Let's call it Twilio, right? This is basically the one that will be responsible for, sending SMSs or sending emails for us, right? So they have all the email integration and stuff like that done, right? So we have again like external system Twilio has come up. So we'll say that the notification service will, send to Twilio that there is a new, post notification, and then we can say, hey, uh, Twilio sends to the reader a new post email, right? And let's say it happens via an email, right? So now if you think about this diagram, or if you think about what we just did, right, we are also able to show these external systems that are outside the boundary of the Acme blog. We were able to demonstrate that also in our particular diagram, right? And this is how you basically, let's say relationship to value. There's some, let's say new post. Yeah. Let's see what's the issue. Some post goes to relationship value and reader. Yeah, I think it should be good. Let's say, that's the issue. Is this the issue? Right. Yeah. So there's some issue with the syntax here, which we're trying to figure out. Let's see. Twilio is already defined. Okay, so the problem is when I called Twilio early on, it automatically got defined, and because it automatically got defined, I cannot like redefine it. So what I'm going to do is I'm going to take this back here. Uh, that should fix things for us. Yeah, that should solve things for us. Yeah, so when I just called Twilio here, PlantUML went ahead and created its own entity for Twilio, but we know it did not allow us to define it again. Okay? So here, we have basically depicted that how the reader gets a new post notification, right? A post update call goes to the event bus, and then a read message occurs from the notification service. It reads from the event bus and posts it to Twilio, and then Twilio sends it to the external actor, which is the reader here. Now, one more thing that we have to add is like the read post, right? This is an action that the reader takes. So let's create that relationship. This is from the reader to, let's say there is a, this won't directly go to the blog service, but there will be like a front end in between. So I'm going to like add that. But this will just show that, hey, the reader is making a call, a read post to the blogging service. Let's say we have internally we need to create another front end. That front end will be like the external front end. Again, we'll call it xtfy, and it's going to external front end. And let's say this is based out of HTML, like plain old HTML, not like any responsive web application or anything like that. Very simple, HTML based website. And we have a relationship. Now the relationship basically has to update to, the reader does a read post on the external FE, and the external FE does a read post on the blog service, right? That's how things work now. Now, you can like further add more features to this use case. Like whenever a read happens, you can again like dump an event, and that event can be used for analytics, right? So here you can see that the external person reader makes a read post call, and the read post call goes to the blogging service, right? Now, if you think about it, blogging service again has to read that particular row from the database. Let's go ahead and add that as well, right? Which basically depicts that the blogging service is going to do like a read post whenever like a new um, read call is coming from the external front end. So this is just going to do a read post row, right? That's another communication that will happen with the blogging database, right? So this is how the container diagram looks like. That there's obviously like the thing about architecture is I can keep on making this more and more and more complex, right? I can add like last time I talked about the search use case, but adding that will just make this diagram even bigger. But the value prop that I'm trying to deliver out of this talk is to talk about, how architecture diagrams are made and not really talk about a really complex, super scalable backend for a blogging system, right? Now, for most use cases, right, for a most homegrown blogging use case, something as simple as WordPress is more than enough, right? Now, the type of system that we are building here is for like tremendous scale and a lot of new features coming on to this blogging system. And this is for those types of use cases, right? For a standard home user, you can just like patch in a WordPress, put a DB against that, and you're fine with that, right? You can put some caching on top of it, and you should be like fine with it. Right? Now we talked about the container diagram. Now the container diagram is something like the 25,000 feet view or the 10,000 feet view, right? The next type of diagrams are called as the component diagrams, right? The component diagrams are more granular. They are talking about individual services, right? Wherein we are individual containers. So a double click on each of the container itself becomes your component diagrams, right? In the component diagram, have your REST resources. You will have the services that actually handle those requests from those resources, the layers that communicate to the database. All those things are the part of the component diagram, right? It's like a further deeper map into how the system looks like. Now for 80% of the use cases, I stop at the container diagram. It's like really not useful to go further down because the patterns are so evident and so clear, you don't really have to model them over and over again, right? If you think about a simple CRUD service, you are very sure that you will have an external, and if you follow on like a hexagonal ports and adapter architecture, you're clear that you're going to have like a out API resource. Then you are going to have like an API resource that gets dependency injected with a some service, and that service will get some dependency injected instances of a external DB client. All these patterns are like super clear, right? You don't really have to model them over and over again. But there are like complicated use cases or complicated system interactions that you have to model. You have to go one level deeper. And for those use cases, it definitely makes sense to create your component diagrams, right? So my suggestion is don't create component diagrams for all your use case, but identify those key critical complex use cases. There could be critical use cases which are very simple or very highly used use cases or high value use cases, but they're like really simple to implement. You don't really have to create a component diagram for those, but for those complex use cases which are hard to fit in your head, you want a way to really break that problem into smaller chunks and solve for it. Then you can like further dive deep into like a component diagram, right? So in this particular for this particular blogging system, I'm gonna like dive deep into one use case, and that use case is say a create post use case. Right here, I want to like go deeper into what are the various classes that are going to be involved when I'm like doing a create post. Okay, so in order to do that, like I talked about the next type of diagram, which is like the component diagram. So let me go ahead and create like a new component diagram. I'm going to call it component PUML. I'm adding the extension PUML just so that Visual Studio Code knows that this is a PlantUML file. Now, I keep repeating this. I know that, but I just want this to be etched in folks' head, so that they remember when they are doing the diagrams themselves. Right? They don't have to come back to the video, see over and over again. I'm just trying to repeat it over and over again, so that I trigger that thought process that hey, this is how you have to do it. Right? Yeah, let's go ahead with the component diagram. Right? In the component diagram, as I said, we are going to deal with the create post use case. So we are going to like dive deep on the blogging service, right? We created a blogging service. I'm going to like deep dive on the blogging service. So in order to do that, I'm going to start with a container boundary, right? The container boundary, and I'm going to call it as blog service, the same name that we used before. So if you see, right, like last time we talked about a system boundary, and this time we are talking about like a container boundary, right? And now I'm also going to bring in this container of admin container here. I'm going to bring that in here, right? Because admin container is the one that's talking to this blogging service, right? But the difference here will be that here I will depict which particular class will be handling that particular request from admin frontend, right? So admin frontend was the guy making the call to blog service. Now I'm going to talk about which particular class is going to handle that use case of a create post. So if you see, there's an empty boundary for that blog service, right? And there is an admin front-end container that's there, right? So now let's create like a simple component here, right? I'm going to call this um, this is like a post resource, right? Let's say it's a post resource. Now, the terminology resource is something specific to JAX-RS. In other frameworks, you could have like other terminologies, but here, let's say there's a entity called post, and any CRUD on top of that entity happens on a post resource. That basically the terminology is entity and resource name, right? So we have a post entity, and we will call it as a post resource. And this is going to be the technology here is JAX-RS, right? As I talked about. So now the component is clear here. So this is a post resource. Now the admin, the relationship that I'm going to write here is that the admin front end, right? Admin front end is going to call to the post resource and say create post. Right? Again, I'm not going to go like super deep and add the request and response body and stuff like that. It's just like super high level. As like the next type of diagrams, this is a code diagram, right? That's when I really start talking about what is the request body, what's the response body. In the code diagrams, you can also have a Swagger as part of your code level diagram. Although Swagger is not really a UML type of diagram, it still is very low level that it qualifies as a code diagram, right? C4 basically stands for context container component code, and the code diagram is like the lowest level, the finest, most granular type of diagram that's there, right? So now we depict the post resource here. We show that the admin front end is making a call to this post resource. It's saying create post, right? Now the post resource, let's say, talks to a post service, right? So I'm going to say it's a post service, and the post service is say based on it's a plain old Pojo, right? I'll say it's a Java based stuff, right? There's no specific technology that's being used in it, right? So you have a post service here. Now this post service again gets depicted in the diagram, and we'll basically show that the post service, the post resource calls the post service to say create post. This is actually a method call that's going from the post resource to a post service. Now the post service can be like an interface, say iPost service, and then there is an implementation of that iPost service, right? All those things are not really depicted in this diagram. That becomes like a further that can be depicted very well in a class diagram of a UML, right? Now you basically showing that hey, a post resource is talking, a post resource is needs to talk to a post service. I apologize. Instead of post service, I had written post resource here again by mistake. But yeah, the intent is to show in this diagram is that the post resource talks to a post service, And the post resource is basically telling post service to create a post. And this is basically a function call, right? It's nothing but a function call. Now we have one more component that this post service is, calling, and that component is basically the DAO layer, right? So we have a post DAO, and the technology can be something like, you can use a JDBI DAO for this, right? So a post service then talks to a post DAO. The post service talks to a post DAO, and the post, it basically says, hey, same thing, create post, right? It's a function call. Saying it's a create post function call right now. If you want to say that, hey, this is not going to be a function call, but it's an RPC, you can just add a comma and say RPC here. Right? For example, it's a remote procedure call. Right? It will just get depicted as an RPC. But yeah, like not diving deep. Let's stick to the simpler use case. And the post service is then like making a call to the post DAO. I'm not going to keep it as an RPC. I'm just going to keep it as a standard function call. Now the final thing that you can depict is you can have like a component DB here. Um, you know the DB that's under this uh, particular system, and you can say, hey, this is the so let's say we'll call it as blog post DB blog post, and let's say the call goes via JDBI, right? And I want to say, hey, this is a relationship between like a post DAO to a blog post DB, and say this is insert post row, right? A very explanatory, self-explanatory of what that actually means, right? Now I wrote this as a component, but it actually needs to be like a component DB. Um, right. So this is going to be like a MySQL database that we have here, right? So that's basically showing how the call goes from like a post resource, or it starts from the admin container, right? It starts way up above, right? Create post here. It goes into a post resource. It does a create post on the post service, and then again a create post on a post DAO, and then finally goes and sits in the DB. Now, if you remember, there was also an additional use case of um, a message event being sent as well, right? An event to the event bus. So we can have like another client here, you know, that's also depicted as a component. You can have a Kafka client, or we can have a messaging client, right? Message client. You can implement it for Kafka, or you can implement for whatever it is, right? It's going to be like a standard Java interface. And again, like a relationship here is going to be like from the post service to the message client, and say post created event, right? This basically tells the message client that hey, a new post has been created, and the message client, let's say there is an external container for the particular event bus. Again, I'm going to just take it from here since you had already defined the event bus container. So I'm going to take this event bus container, just put it in here, and I'm going to say like, hey, the post service, the message client is going to like, message client to the event bus post created event, right? So basically, this passes a post created event, right? So this is the next level, right? So now as we go deeper and deeper, our architecture is becoming more and more clear, right? How stuff works in the system becomes super clear now. We know that post service fans out two calls, one to a DAO layer and one to a message client layer. Now you can think about, various edge cases that can happen here, right? What if an event goes through to the DAO but does not go through the message client? Do we care about that? Do we have some, fallback for it? All those, things are like much easier to think about now, right? Or like what happens when the message client is not able to talk to the event bus? How should we handle that? What happens when the post DAO is not able to insert a row? How do we handle that? A lot of use cases like that. For every arrow you can think of the success scenario for it and the failure scenario for it, right? So that way it's very easy to break down, the way we thought about this, right? We started at a 50,000 feet view and we broke it down a little, right? We went to the 10,000 or 25,000 feet view with the container diagram, right? Now we are coming down even lower, right? We just came down to like a 500 feet view right now. We're very close to the code, right? And then the next step is now as and when we come down and down and down, every scenario we think of all the edge cases. What are the positives that can happen? What are the happy paths? What is the negative path? We take two individual components here, or we take two individual containers and see all the arrows that go from one to others. There will be a happy part to it, there will be a sad part to it. It's very easy to reason about things now, because we have broken down a complex system into a much smaller, simpler set of components that together holistically bring out something that is much bigger than the sum of its parts, right? Now, let's go down to the final, diagram, right? The final diagram is the code diagram. Now, code diagram is as simple as your sequence diagrams, and you will have like a multiple code diagrams. So, for example, in this whole create post use case, you have like a sequence diagram, right? Sequence diagram is also a code diagram. You can have like a class diagram. You can have an activity diagram. You can have like so many types of code level diagrams. The thing about code diagram is it's nothing but your UML diagrams or your Swagger. It's very granular, right? So you don't really do it for all the use cases. You just do it for the important use cases that are difficult to fit in your head, right? Um, so yeah, I mean, it's as simple as you just create this. So let's talk about the create post use case itself, right? So you have a very simple post resource talking to a post service saying create post, right? Now this can have two scenarios: alt, success, right? In the success scenario, basically, let's say the post. In the success scenario, the post resource gets a response back from post service saying, success, right? And the post service then, responds back to the actor, right? Let's say we'll introduce an actor also, actor, user, right? Yeah. So user, let's say, says post resource, saying, hey, create post, right? And the user gets response back from the post resource saying success, or you can have an else failure. Post resource gets a failure message from a post service, and user gets like the same message back, right? From the post resource, they get a failure, right? And you do an end, right? Again, like we can go much deeper into this, but the whole point of this talk is not to talk about how sequence diagram works. I'm just saying that the final step here in your diagramming is your code diagrams. You can have as many code diagrams as you want. You can have as many component diagrams, as many container diagrams, as many context diagrams as you want. The whole idea behind it is you start at a very high level, 50,000 feet view, and from there and then on, like you start dividing your problems into sub problems, then reason about them at that level, right? And then further you divide your systems into more sub problems. You think about those sub problems. Again, you divide them into further sub problems, right? So you're basically dividing and conquering your whole problem statement, right? And that helps, you create a much better, much robust system, right? Because you're not reasoning in an unstructured fashion, right? You have some structure over your thought process, and when you have that structure over your thought process, um, you can reason better. You can find those edge cases much in a cleaner way. Your system architecture just becomes more and more beautiful, right? That's the benefit of having proper notations, right? We as humans are able to reason about things so well because we have a tool called language, right? Similarly, we as architects are able to reason about our architecture in a much better way because of tools like this, because of proper diagramming, because of proper notation, and because of proper communication as well. We shouldn't forget the communication aspect of things, right? Because if and only if we are able to communicate properly to our peers, the other architects, of how our system looks like, will we be able to get feedback from them, right? If they have like a very crisp, clear understanding of our system, right, they will be able to find those edge cases that we have not covered, and they will not talk about those edge cases that we have already covered and not depicted properly in those images, right? And therefore it makes those conversations much more useful and much more fruitful, right? So that's the whole summary of the C4 diagram, the tools that we used. Just take a minute to recall what we just talked about. We talked about the toolings that we have. We talked about Visual Studio Code. We talked about PlantUML. We talked about an extension to PlantUML that enables us to write very beautiful C4 diagrams in PlantUML itself. By default, PlantUML does not support C4 diagrams. The link to that particular extension will also be given in this the video description. We also talked about a plugin for Visual Studio Code that enables us to write PlantUML stuff in a very beautiful way, right? We then dive deep into the C4 diagrams. We talked about the Acme Corp's blogging system. I'm pretty sure if some company implements this type of blogging system, scaling for them is going to be like a walk in the park, right? They don't really have to worry about scaling the system up. That's what we architects are responsible for doing, right? We are responsible for making sure that the systems that we build are like massively scalable. The systems that we built are meet the business goals, meet the long-term goals, and meet the fault tolerance goals, n number of system goals that we have, and also the long-term extensibility goals that we have, right? And these types of diagramming notations really help us do that even better. I'm just gonna sign off with saying that hey, I hope that this type of diagramming really helps you think about architecture in a much better way. I hope you found this whole video super useful. If you do, please share it with your friends, share it with your fellow architects, share it with fellow peers, junior developers who are aspiring to go in the architecture route. I'm sure they'll find this super helpful and super useful. Feel free to drop in any feedback if you have. Thank you so much.